Hello and welcome back to the lab. Today on the bench we have a HP 4278 capacitance meter. I have been actively trying to get a better LCR meter for the lab for quite some time. This will fit some of the bill. This is just a C meter, so the 4278 is not an LCR meter. It is just a capacitance meter. But that's okay, because capacitance is what I've been hurting for the most. My LCR meter, which is a very serviceable unit, don't get me wrong, has been the DEE LCR meter DE5000. Still available. You can still buy this meter new, and it's a great addition. I made this set of probes. This uses a weird plug. The BNCs, banana jacks are dead. It actually uses the PCB to integrate here with guard and plus and minus. And so that slots in like so. There's also a tweezer probe, which is highly useful for SMD components. But the one that comes with it is this very, very short TL21, which is good, but I wanted something a little bit longer to get into places, so I ended up buying a cheap set of probes off of Amazon, taking the BNCs off and putting the BNCs onto the cartridge. That does degrade the measurements a little bit for the way these work. As you can see, we have high current, high potential, low current. And the ideal is for those signals to merge as close to the measurement as possible. With these professional capacitance meters, we have fixturing that goes right here where the testing is done right here. You want these leads to be as short as possible. Splitting them out does add accuracy, but it can only go so far. So having very, very short lead lengths for capacitance measurements just increases the measurement, or makes the measurements a little bit better. Been looking for one of these for a while, and this one came in with some of the gear we picked up. But as everything that hits this bench, it didn't quite work just right. So I was not originally intending to do a video on this. I was kind of working on this unit side by side while I was doing some of the DC calibrators and things. So while I was waiting on parts for the DC calibrators, I was fiddling around with this unit trying to get it working. And I will admit I spent way too long finding out what the problem was with this unit, and it drove me nuts. But that's what makes this video interesting. Hence the reason why I decided to record for the channel. This particular unit originally came in as it had a power supply problem. So when I tossed it up on the bench, plugged it in, did the requisite checks, fuses were okay, threw it up on the bench, and essentially the screen was dead. I could actually see it boot, which we can actually show you guys what it did. I could see it boot, and but there was no backlight. The screen was dark. Contrast did nothing. So the screen was either dead or wasn't getting signal. But you'll see, you may not be able to see. I'll get a flashlight, see if I can make it do it. But it'll have like a blacked out portion of the screen, and then that goes away. So the screen's at least trying to function. It's just not. So at this step, it's measure power rails. Okay, now that's where this gets a little weird for this particular unit, is there is a ton of power rails in this unit. Up here at the top, all of these are different power rails. We have ground point for all the power rails, but then we have -15, +15, -12, +5, +8, +12, and that's just for this board. If you go deeper into the unit, and we pop out, say, this board right here, we have yet more power rails. We have +5B, +5A, -12, +12, not an A or B, and then a test point ground right here. So we have AB 5 volts power rails, +12, -12. And you'll note these caps have already been refreshed. That gets into some of the troubleshooting, trying to figure out what was going on with this thing and why it was so strange. Popping out another card. This one has a myriad of power rails as well. Those are not power rails. Sorry, those are phase detectors. Okay, so this is the phase detector. The logic card does have test points and yet a few more power test points, things like that. So we have lots of A and B power rails on here, which I have gotten a fair few amount of questions as to why I have so many DMMs. This meter bank, which is currently off and cold, power this on, is for testing multi-rail devices. I hook up one power meter to each rail. I usually run a ground lead off to give it a common ground for what needs a common ground. Sometimes you have to be careful with that for supplies like this that have A and B power rails. The grounds aren't necessarily shared. You'll have isolated grounds for the B supplies that won't necessarily reference the A supplies. So hooking the ground leads up independently is sometimes necessary. Commingling the grounds can actually short some things out, but is always ideal, sometimes critical. So everything fired up, measured, lots of power rails, everything measured okay, except plus minus 12 volts was gone. So if we come down to the top of the unit, plus minus 12 was gone over here. Not a B supply, but plus minus 12 was present over here. So I'm scratching my head trying to figure out what's going on. Obviously pull the power supply out. Plus minus 12 volts being gone here probably is a power supply issue, most likely. First step is let's check for linear regulators. There is no schematic available for this power supply, so I was flying blind. But the obvious ones is let's find the linear regulators, see if one of them is dead or not. And I'm sitting here just really looking for linear regulators, and I'm not finding anything. So we have big bolt caps down here. The 12-volt test point comes down here to test these caps and then goes into this connector. So that leads me down the path of thinking possible distributed power supply where they ran out of room for the 12-volt regulators because this isn't marked as a B supply, but it's not working. So one of the things in my thought process was 12 volts comes to this board, gets regulated and filtered, and then comes back to the supply to charge the bolt cap that then feeds possibly the rest of the system. There are some things that run distributed power supplies like that. Not ideal, high current being on the PCBs, things like that. So that would have been a design choice. But I just could not find any linear regulators for the plus minus 12 volt rails other than this card. So toning things out on the board, tracing things out, following signals, everything fed back and forth through the multitude of pins in these connectors right here, which was just kind of driving me nuts. So I tried power injection. I'm at a point where I know what the problem is. Is it worth the rabbit hole of diving down and fixing it? This is an incredibly high value unit, so if I could get this fixed, the rabbit hole would be quite useful getting this up and running for the lab. But is it worth the time to really debug this, dive in? Am I opening up somebody else's project that multiple people have been in here once or twice or more? And do I have a whole bunch of bad cards? Do I only have one bad card? So I needed to get the unit up and running, at least to show me a display. If it shows me a display, perfect. Then it's worth fixing because that means I have at least the unit has a brain, and my plus and 12 volt rails being missing were my ultimate problem. Definitely a problem. Didn't know if it was the problem or a problem, which is what we were trying to fix. So we did some voltage injection. Picked up the Rigol from over there, clipped it in, and wanted to see if we had power supply and life. Turns out, display fires up. I get display, processor boots up, everything's good to go, and everything looks fine. So, okay, we've validated the problem now. Back to why do I have 12 volts here, but I don't have 12 volts here? Keeping in mind it's both 12 volts, plus and minus, no plus and minus. So I kept coming back to, is this a power supply problem, or do I have something else going on? I was even thinking board opens maybe, like if it was a distributed power supply. So the next step was to take the plus minus 12 volt test points here because it didn't say B supply, it just said plus minus 12 volts, and clip them over to the power supply and see if the machine booted up. And it did. So I'm sitting here going, okay, do I have a weird board fault where the motherboard's not getting the plus minus back from here to over here? Because there's a significant, on this PCB specifically, here's a significant 12 volt supply here. Here's my 12 volt regulators, plus minus 12 volts. They connect to the 12 volt test points. Everything looks okay. Signals come in and out from the connector at the bottom. And so thinking they ran out of space for the regulators, put them on here, and we have a distributed power supply. Because again, 12 volts here, no 12 volts on this side. Unit fires up. Everything fires up. Things are working. I checked the isolators, thinking maybe some feedback was... busted, things like that. I'll leave this right here for purposes that will become clear a little bit later in the video. Rebuilt the entire capacitor string, still thinking the 12 volts leaves, gets regulated, and then comes back. That thought process ended up being completely in error. And man, is this power supply weird. So if you'd like to think on this for a while before I give the solution as to what actually happened, or what I think happened, which we're going to find out, is pause the video here and see if you can notice what I've seen on this board. Okay, so I'm going to take this cover off real quick. The solution is not under the cover, but I want to show something because I'm still looking for regulators. Like, I haven't found 12 volt regulators, so I'm still scratching my head like, how are we getting filtered regulated 12 volts out of this thing when I haven't seen any what I would consider traditional power supply functions? Regulators, the bulk filters are at the bottom of the board. Those are easy to find because those caps are pretty big. A lot of this HP gear needs really quiet power supplies, and that's part of the process. So with the cover removed, I should say. So our bulk filters on this supply are down here for all the different power rails, different capacitor voltages, things like that. Everything's fine. This has not been plugged in for days, so me handling the bulk filters on the input side is fine. These would be charged up to a significant voltage on the mains. Rectifier here, into these, and then I was looking for chopper silicon and rectifiers, and I can't find one. I have some active silicon up here. These are all rectifiers. There's no linear supplies or anything like that in any of these ICs. These are all CRs and they're all rectifiers. So sitting here scratching my head going, where is my regulation? How does this thing actually go? So these two, I believe these were FETs when I checked them. These are the switching FETs. So these drive the switching supplies, which then wake up the rest of the unit. But the weird thing is, if you trace the board out, these drive this transformer. This transformer then drives that transformer. That transformer then drives that transformer. So we have a 3-stage switching supply generating a myriad of voltages. So we have switching action that's happening for sure because we're getting some voltages out of this, just not all of them. But I get nothing out of this transformer. Looking closer, right there, if I can stabilize this, and the camera decides to focus, there's 2 fuses missing. Not gone, not blown, completely gone off this power supply. They should look like this right here. Fuses. So I was checking all these fuses, and everything was checking good. No problems, no blows, no opens, except I wasn't looking for missing. So not sure how that happens over time, but somebody has harvested the 2 amp, as it's labeled, right here, F6 and F7 are 2 amp fuses for the 12 volt supply. I'm assuming, because everything else is working. So let's put some 12 volt fuses in there. 12 volt. Yeah, 12 volt 2 amp fuses in there. And see if this thing wakes up, comes back to life. All right, for those playing along at home, you are doing so, if you are following along, you are doing so at your own risk. But here's part number. So 2 amp, 120 volt AC, DC axial fuses. Very tiny things. Sort of look like resistors, but they're actually fuses. So let's see if we fired it up. I got power applied, haven't turned it on yet. So if we get backlight and we get display and we get booting, we'll have a resolve and we'll finish up redoing capacitors, things like that, getting this thing ready to go. But let's see what happens. Will we blow the fuses again? Well, that's a good sign. The display is not straight. It's very off, so we'll have to address that, but that shouldn't be a problem. We have a functioning device. All right, so the fan, I don't know if you guys can hear it in the background, but that fan is awful. I'm going to work on that growling fan, and then we will finish getting this thing up and ready. Well, this was actually a quite serviceable design, and I actually rather like that. This ribbon cable comes off. The main power cord goes into this plug, and then the fan comes off from this header, and this header comes off the main board, and this whole back panel comes off, fan included. Fan is in there with some Allen key bolts, so we'll get them taken off, and then we'll get to the bottom side of this and see what kind of fan we're dealing with. Okay, so this thing is a very oddball fan. It's a Sanyo, which isn't surprising. It's a DC Sam Ace, brushless, which is good, so probably our noise is coming from bearings. But it's in a aluminum frame, plastic blades, and the aluminum frame, I'm sure, is for some shielding, so we're going to want to preserve that. So I think what I'm going to do is I'm going to disassemble this fan, and I'm going to see if we can't get some grease in there and get this to quiet down. If it ultimately comes to pass where we have to replace this, we will, but let's see if we can get this one up and running. Well, I don't know how well the camera is going to show this up, but I found the bearing noise. This is absolutely chewy with crud, gunk, and terrible on here. So I don't know if this bearing is shot or if it needs to be cleaned and lubed or anything like that, but definitely needs some clean out. Here's the motor, the controller. So we're going to definitely take care of this bearing situation. I may just, well, this fan would be very easy to re-bearing too if I could get a size for these specific bearings, because it just popped out the front and the back. So I should be able to push this bearing out, I think. Yep, there it goes. So here's the bearing the fan runs on. So it's a mechanical issue. We'll see what we can do about addressing that. All right, well, this fan was absolutely filthy. A ton of stuff came out of here. Looked like rust, so I don't know if this got wet at one point in time or not, but I found our growl. This is the bearing that's actually bad. It was the back bearing. I don't know. It's really not showing up well, but if you see this part sticking out of the bearing, so that should not stick out like that right here. This should not stick out of this bearing like that. This bearing internally has been destroyed, or has destroyed itself probably. I don't think it got abused. I think this fan may have been wet at one point in time due to some rust, but I don't think it's too bad. I'm going to need to clean the frame still, but yeah, that's our growl. Was this bearing has self-destructed. I do not know what this bearing size is. I don't know if it's stamped, if I could get one. This is a standard small size bearing, but I don't know if I'll be able to source one, so I may have to grab one from another fan. But we'll see what we can do. Okay, let's fire it up and see if the new fan is quieter. New bearings. Here we go. So much better. It's not growly anymore, and everything's up and running. Very, very quiet. I did add a little bit of oil to the bearings. Hopefully it seeps in past the shield and actually decides to help out. And we booted and everything's fine. Next up on the list, this display. Let's get this straight and cleaned up. Okay, the display was a boring lack of hardware, so the bolts were just not in there, which caused the display to drop down, and that's why it was off a little bit. So we're going to go ahead and finish up the recap on the boards that haven't been done, and then this thing's going to be ready for some burn-in testing. We are cleaning as we go. I need to do some more cleaning on the front panel, get this crap off of here, and a couple of other things. But everything is starting to look really, really good. All right, here we are. All the covers are on. Everything appears to be good to go. Let's see if it'll actually measure a capacitor or if we've done it permanent damage. So I've got a set of 2-wire leads hooked up, or I should say 4-wire leads, 4 B and C's. Cheap set from Amazon. No, nothing crazy. Although, for what I paid, these are very high quality leads. Can't complain. And we have a 0.47 400 volt capacitor. Survey says, well, 0.477. And cable is 0 meters, so we do need to fix that. Let me adjust the... There we go. Make it easier to read. How did we do that? Oh, we could turn the average rate... Get some more averages so it runs quicker. Cable length. We'll make it a 1 meter cable. Should get a little more accurate now that we're taking into account cable capacitance. 0.47715. So not going to complain about that considering we haven't adjusted, calibrated, or aligned anything. I got to find a calibration document for this thing. All I can find is the operations manual as opposed to a cal document. So, but we're working. I'm going to let this burn in. Make sure it doesn't have any other problems. Draws about 50-ish watts once it's all warmed up, so not too bad. And we'll go from there. Okay, so after 6 or 7 hours of burn-in, everything still looks good. We're still measuring quite well. No problems on the unit. And these probes are holding up pretty good. Next stop is the lines in the display. Very faintly, if I knock it, if I push a little bit, you can see they'll come and go. That is the ribbon cable on the LCD making and breaking connection. So there's some stuff we can do about that, not a lot. Best thing would be to get another display. But so I'll have to look into sourcing a LCD panel for this particular unit, but it is functional as is. The lines will come and go. But the main measurement window is still working. Just some of the stuff at the top is aging out. This is probably a high hour unit. It's run quite a while, just from what I was able to see. So having a little bit of LCD fault isn't completely off the rails. But measurement-wise, quite functional, and everything's good to go. So next stop is I need to get some fixturing and go from there. Thanks for stopping by the lab and taking a look at this 4278A. Bringing up our capacitor measurements into a far higher accuracy realm than we were before, within the limitations of 1 kilohertz and 1 megahertz. If you like what you're seeing, hit all the YouTube buttons, like, subscribe, and bell. And if you'd like to check out some additional content, as well as possibly support the lab, take a look at the Patreon page. Patrons help keep the lights on here in the lab and videos coming up to YouTube, and their help, as always, is incredibly appreciated. They're running a little bit ahead on videos, so if you'd like to sneak peek as to what's coming out to YouTube, head on over there and check it out. With that, as always, more's on the way, and I will see everybody in the next video. Bye for now.